Hello and welcome to this AWS course. In this video, I'll show you how I generate Terraform using AI, and more importantly, how I control output so it's actually usable in real projects. Because by default, AI can generate code, but not always in a structure you would want to maintain. We will create via Terraform MCP the Terraform structure that we need. For this, let's in a Claude write something like create a Terraform project structure for deployment security group and EC2 instance. With attached new security group on AWS. And let's say that use models for this Terraform registry where it's possible. Like the target, put Terraform files in the Terraform folder inside of this project. And run. Give him a second. Confirm the action. Perfect. As you could see, on top that latest version provider, MCP HashiCorp AWS is in use. And basically this is it. Now we need to wait when Claude Code will do the research and build the initial structure for Terraform scripts. Confirm the creation. And we see Terraform folder with files already. Main, variables, versions, and outputs. Good, it was finished. We see this Terraform scripts. We have security group with inbound allowed traffic on SSH, HTTP, and HTTPS, and the instance with the T3 microtype. Also Claude, to us give the instruction how to deploy them, with arguments if we need to change type or region. So now let's go a bit more deep here. Open main TF file, and we could see that it's actually not a model that Claude write. It's still according to the best practice using existing HashiCorp security group model. And the same for the EC2 instance. So technically, if we will run this Terraform scripts, in the background it will refer to the official model of HashiCorp AWS and execute them with the specified parameters. Also inside of the variables and outputs file, we have no standards yet. Same about the provider information. For example, each instance now will be created with the variable name and the instance prefix. This is decision were done by the Claude based on the HashiCorp best practice. But what if we want to use our own standard? For this, we back to already know file CLAUDE.md. I have already prepared the prompt for it, so let me share with you. So let's tell to the Claude that I'm building Terraform project that will deploy AWS structure. We ask him to create a good CLAUDE.md file for this repo and set the goal that we need to have it based on a best practice. But before writing the final CLAUDE.md, let's ask him to analyze the structure and document it properly. And later we can put the list of the requirements that we have missed previous time. Let's start from the Terraform requirements. See that preferred Terraform AWS models from the Terraform registry to make sure that we align with the best practice. Terraform should organize resources in a modular structure that we missed on the previous time, pin version of each module, and now the most important, let's say that run fmt command before trigger any plan. It will allow us to make sure that formatting of files are correct. Also, let's ask to make sure that plan action is succeed before pushing any changes to the Git. That will protect us from the problematic code pushed to the repository. Now about the replacements. We are asking for manual approval before comes any replacement. Like the destroy, let's deny at all for now, to make sure that our AWS structure is in safe. This section provides to our project clean view, how we want to see Terraform scripts to be used here. And actually we can do the same for others. Like documentation, we could say that please include to each module README file and requirement to describe not only module, but also inputs, outputs, and the usage there. For Git, we could set which case should be used for write. So yeah, need to correct the name. Also, split section for pre-push. Again, fmt command to show that it's aligned across all scripts in a project, succeed validation of Terraform, and same about the plan. Print all resources that we are changing in a table view for better visibility, and mark them accordingly. And only after that we can do the actual push. For AWS, I will specify configuration that I wish to use for this section, like the region, default instance type, attached public IP, tags, project and environment, and the naming convention. Also, networking is also very important section, like we are going to use right now the existing VPC and the public subnets. Without it, Terraform can be crashed, because it will ask you to create the VPC before. Next, operational expectation. Means what after apply I want for sure to see. On our case, it's the URL with the public IP of the instance that I just want to open on a browser. And event, provide basic section suggestions, but ask Claude to do the final decision. Let's feed this request to the Claude Code and check the result. Okay, Claude starting to read CLAUDE.md file and write the new version. It's not going to take a lot of time, so let's give him a second. Okay, we see the file has been changed, and the sections were generated. Now our CLAUDE.md is much bigger than was before, but it's still wrong. We asked Claude to change CLAUDE.md based on the current infrastructure and the requirements. And this is actually Claude did. He describes current Terraform folder, but this is not our target. We want to create new one from the scratch. So let's do this again, just before remove Terraform folder that we have created, and together clean up the CLAUDE.md file. In the console, type fully same prompt that we just did before, and you will be surprised from the difference. Great, all sections and the key points we have open CLAUDE.md, and finally we got that we wanted. We also have the models directory with which Claude will work. Later we set the naming convention together with the tag standards and all other information that we already fed. To confirm that Claude now understands us like we want, run the same command about the generation Terraform project, and we'll see. And we have the first files. versions, variables, outputs, and main TF files. Same like we had before. But now we also got the models folder. And inside of this folder, we have another one for the EC2 instance model and for the security group. That means we will refer now on the local versions of the model, not on HashiCorp that we had before. This is exactly perfect match that we wanted to, and it gives to us much more control, like now we are control resources that we are installed. And it's done. So now when you open main TF, we can confirm that EC2 model now pointed on the local model. The name like we set on the configuration, and the text that we want to be applied. On the top we can find this text and the name conventions. Perfect. Now we could see how correct settings affect the execution, and why it's so important to set correctly before any execution. AI is not the hard part anymore. Designing a workflow you can actually trust in a production. That's where things get interesting. This is just one piece of that workflow. In the full course, I walk those the complete system, from generation to deployment, with guardrails and automation built around it.